Suppose that we want to compute the following integral given by 1 over x minus square root of x plus 2 dx. The first thing that we need to have is we don't want to divide by 0. So that's why we require that x be different from the square root of x plus 2. Okay? And also we want the square root to be defined. That's why we require x to be bigger than minus 2. We will see if we're going to see if we have strictly bigger than minus 2. Okay, to find this first condition, we can simply just, we can graph the square root of x plus 2 and see where it intersects x. So we know the graph of x. Okay, very easy to do. 1, 2, and the square root of x plus 2 is just square root shifted 2 unit to the left. Okay, so here, okay, we will see that they intersect at this point too. So this is a problem. So, and we can see it from here. So if x is 2, we have 2 minus square root of 4, which is 2, we have 0. So we have to get rid of this one. Okay, so that's the only issue that we have. So we can make sure that we are in this interval, minus 2, 2 union 2 plus infinity, to make sure that we are in the right track. Next, to get rid of this square root, the best way, and I believe one of the easiest way, is just to define a new variable, we call it u, and make it equal to the square root of x plus 2. Okay, once we do that, we can compute du. It's going to be equal to 1 over 2 square root of x plus 2 dx. And we know that du is 1 over, this is just u, 2u dx. And finally we get 2u du is equal to dx. Okay, next we compute x by squaring this one here. Okay, so u squared is equal to x plus 2, and we get u minus 2 is x. Okay, so we're gonna plug it here. Okay, and plug in dx as du. So we're gonna find that this one, the I integral, is equal to 1 over x is u squared minus 2, and the square root of x plus 2 is just u minus u, and dx is 2u du. Finally, we take the 2 and we leave it outside. We get this integral u over u squared minus u minus 2 du. So we have this fraction here. Okay, so we need to factor this fraction. Okay, so an easy way to do that is that we see that u squared minus u minus 2 is equal to u squared minus 1 minus u minus 1. I had to split 2 into minus 1 minus 1. Okay, so here I get minus 1 times u plus u minus 1 times u plus 1 minus u plus 1. So this one, by factoring by u plus 1, I would get u plus 1 times u minus 1, which is minus 2. So here is equal to this one. Okay, so now I'll bring it here and I get I is 2, I'll keep the 2 outside, u over u minus 1, u plus 2. Okay, du. Why I'm doing this? Because I need to compose this fraction to make it easier. Okay, or I can just say that this one can be decomposed as the following. Since this is 1 degree 1, this is degree 1, this can be written as, so u over u minus 1 times u plus 2 can be decomposed in the following manner. Okay, if I get more space here, I can write more. So I think I have more space here, so I can write here. So I can do more here. I can write this one as a over u minus 1 plus b over u plus 2. Okay, and once I do that, I can just cross multiply to get the result that I need. So here I have multiply and get u. The factor of u is a plus b, factor of u plus 2a minus b over u minus 1 times u plus 2. Okay, so here I can solve this system because I want to make sure that these factors are the same. So I have a plus b is 1 and 2a minus b is 0. So I have to solve this system. A plus b is 1 and 2a minus b is 0. Okay, so the second one gives me that b is just 2a, and solving for a, I get a is 1/3 and b is 2/3. Okay, now my integral, this integral becomes, I had to keep the 2 outside. Okay, so I have the b 2 over 3, 2 over 3. So I can factor by the 2. So I have 2 over 3, okay, 1 over u minus 1 plus b plus 2 over u plus 1 du. Yes, so this is what I have. Okay, so I can check by just cross multiply, or I can, here now I can see what I have. This is the log of something, so I can do, this is 2 over 3 ln of u minus 1 plus, let's keep the 2 over 3 outside. So I have 2 over 3 plus ln of u plus 1, the 2. Now I can put back u. Okay, so to put back u, I have 2 over 3 ln of square root of x plus 2 minus 1 plus 2 ln of square root of x plus 2 plus 1. So I'll write it nicely in a separate sheet because I don't have enough space here. I can do it here. So I have the final integral as u is equal to this value, 2 over 3 ln of u minus 1 plus 2, okay, sorry about this movement, 2 ln of u plus 1, and I know that u is square root of x plus 2. So I go back and I put that. So I have 2 over 3 ln of square root of x plus 2 minus 1 plus 2 ln of the square root of x plus 2 plus 1. Okay, so I would keep this one here, this plus c. I forgot the constant. So I would keep this one as it is, because I can get the 2 inside and 2 over 3 inside and using the multiplication for the log, but using the calculator, this would make a lot of computation and storing for the the calculator. So it's better, it's less work for the calculator, and it's okay, it's logical and it's correct to keep it like this.